Okay, this morning we're going to talk about combining like terms. So this is another way to simplify expressions and make equivalent expressions. So it starts off as Miss Vera's science class collected the following items on a nature walk. Group the like items together and determine the total number of each item collected. So you could pause the video here, figure that out for yourself, then restart. Okay, so to find the like items, I assume you grouped them by their similar things. Like the flowers, there were 7. And then the leaves you also grouped together, right? 4, okay, and 10 leaves. Okay, we can do something very similar when we're trying to simplify expressions, particularly algebraic expressions. So it says algebraic terms can be grouped in a similar way by combining like terms. Okay. So like the leaves and the flowers, we can put together things that are alike and then simplify the expression. So what is a like term? Algebraic terms are considered like terms if they have the same variable with the same exponent. If I'm going too fast, you're going to pause the video and write it down. Next, we'll keep in mind that constants are like terms since they don't have a variable. And if you don't remember what a constant is, that's a number by itself. Okay, so this next one. For each set of terms listed in the table below, circle the 2 like terms and cross out the unlike term, then explain your thinking. Okay, so we'll do this first one together. We've got 3x, 3y, and 4y. We have to decide which one would be like. And according to this definition, they are like when they have the same variable and the same exponent. So that means 3y and 4y are like terms, and 3x is not. Why? Because they have the same variable with the same exponent. Okay, I want you to pause the video here and try the next 2 on your own, then come back to check. Okay, hopefully you're coming back to check. We've got 10x, 5x, and 2x squared. The like terms are the 5x and the 10x. Unlike is a 2x. You have to have the same variable with the same exponent. Okay, and then your next one, 10, 7x, and 7. Your 2 like terms are the 2 constants. And I'm just going to put constants are like terms. And then the x you cannot combine with the constants. Okay, moving on. Next, use algebra tiles to model the expression in 2 through 4. Then use the algebra tiles to help you combine like terms and record a simplified expression. So in our first one, they already drew the algebra tiles. So we're looking, we've got 2x and 3 and then 3 x's. So we're going to combine the things that are alike. So all the x's, that makes 5x, plus we have just 3 other things. Those are the constants. So 5x plus 3, is the simplified version of that. These are also equivalent expressions. Okay, we'll do this one together. If I'm going to draw this as algebra tiles, 4 is going to be represented by 4 1-unit blocks. Again, you may have to pause to keep up with me. I'm trying to talk fast so this video is not crazy. crazy long. And then 1x, and then 2 x's, and then 1. Okay, so when I'm combining them, I'm looking at that 3 x's plus an additional 4 units. So 4 plus x plus 2x plus 1 simplifies to 3x plus 4. These are equivalent expressions. And then our last one, we're going to model here with an x plus 3, 1 unit cubes, an x. And then I have to pay close attention because I have a minus 1, so I'm actually taking 1 away there. So you have to watch out for the signs. Okay, so I've got 2 x's, which I'll represent as 2x, plus 2 units. I'll put that there. Okay, and this is called simplifying expressions. When we combine the terms that are alike, then we can make it easier for us when we find out what x is. Now I only have to multiply and add. Before I'd have to add, subtract. We're trying to simplify it. All right, on the back. We can simplify algebraic expressions by combining like terms. Nobody wants to draw those algebra tiles every time, so we have a simpler way to do that. We're going to identify the like terms. We're going to be careful to keep the symbols in front of them and then combine them to make a simplified expression or to simplify. All right, here's the example, what I'm talking about. 9x plus 8 minus 2x plus 1. I like to use a circle first. So 9x, I'm going to look for anything that has an x, and I have to include the symbol here. This is a minus x, that's going to make a difference. Those are all the x's. So then I'm going to choose a different, I'm going to try a square or a rectangle. Like a plus 8. That's a constant, so I have to look and see if there's any more constants, and there is, plus 1. Now I can combine them. 9x minus 2x is 7x. Then I'll put these together. 8 plus 1 is 9, and it's a positive, so I'm going to put a plus sign here. All right, and then that's my simplified expression. All right, we're going to keep going. Color code or use a shape to identify each term as shown in the first example, then combine terms to simplify. Okay, we've already done that, and they did the first one here for us. So we've got the x's. They are like terms, so you can add them together because there's a plus sign here. 11x plus 9x is going to be 20x. Then all that's left is a plus 19. Then we have our simplified expression. Okay. Moving on. So again, 14x. I always start with a circle, then I look to see if there's any other like terms. There is an x. Make sure I include this minus 5. And then looking for any others, and there's only a y, so I'm going to use that. Then I'm going to combine 14x minus 5x. That's a 9x. And the only thing left is a plus 3y. All right. That one's done. Moving on here. 16c, and then I have a plus 5c. Next I've got these constants, then I can put them together. So my circles, I can write it out like this, or I can mental math it. 16c plus 5c is going to be 21c. 9 minus 3 is going to be 6, and it's a positive 6. So we have plus c, or plus 6, sorry. Okay, I know I'm going a little fast again. I'm trying to make this video a little bit short, so I apologize. You can pause and slow it down. I would like you to try these on your own, except before you do, let's talk about number 7. 4d minus 8 minus 3d. So we've got 4d minus 3d and then a minus 8. Okay, so I'm looking at my d's. 4d minus 3d would be 1d. And then minus 8. Okay, we have to think back to the identity property of multiplication. Anything times 1 is always itself. So we are just going to write this as d minus 8. Okay, that's 1d minus 8. Okay, you'll see that also in, let's look at number 8. All right, I've got 8x squared. There's nothing that is the same as that, so that's by itself. It has a square. Then I've got some x's here. These are like terms. There's only one x. I have to recognize that in front of that x is an invisible 1. We just don't write it because anything times 1 is itself. Okay, so then I can simplify it. 8x squared plus 11x. And then we're done. We cannot put these together. If it has an exponent and this one doesn't, they are not like terms. All right. Number 12. Let's look at that one. People get a little bit confused on that, but if you look, all we have are d's. They're all like terms, so then you're just following the order of operations. 15 plus 3d will be 18d minus 7d minus d. Again, remember, there's a 1 in front of that. Subtract 11d minus 1d to leave us with just 10d. So when we work this out, it will be a lot simpler. Multiply and you're done, rather than multiply, add, subtract. So the idea is to simplify it. Okay. And then the last one we're going to do together here. It says write an expression to show the perimeter of the rectangle. So you have to remember what the word perimeter means, and it means you're adding all the sides because you're finding the measure of the outside. So you have to remember, you have to include all the sides. And then I would write it out. 2w plus 7w plus 1.5 plus 2w plus 7w plus 1.5. Okay, that's a really long expression that we would want to simplify. So by looking for all the w's, including those symbols, okay, and then we're going to put those together. This would be 9w, this would be 9w, and then we'd add them together to make 18w. Then I've got 1.5 plus 1.5. They combine to be 3. And then I do that here. That's much simpler. And then, I know I said that was the last one, but let's do this one. Miss T wrote an expression on the board shown below, but parts of the expression got erased. She knows it simplifies to 10x plus 13y. Find the missing values. So give it a pause here and try to figure this out. Okay, hopefully you tried to figure this out. So you know there's something x minus 2x, okay? How can I end up with 10? You should recognize that you'd have to have a 12x minus 2x. And with the y's, 8y plus something y to equal 13y, recognize that that has to be 5. All right, I want you to do the rest of these on your own and then come back and check your answers before moving on to the homework. Okay, you should have already done these, so I'm going to kind of move fast. Okay, I've got two constants. This is going to be 11y plus 14y. I've got a plus 3a. That makes 14a minus 5c. Next, w, then I've got my constants. 16w plus 5w is 21w. Plus 14 would be my final answer here. Next, r minus 11r, and then I've got my q's. 18 minus 11, 7r, 7q plus 13q plus 20q. T's, and then s's. All right, so 6t plus 2t is 8t. And then I need to erase these so I can see what that says. Okay, plus. Plus and a minus. So I'm going to end up with a 9s. Last one. Here, 4x squared plus 14x squared, 18x squared. This one's all by itself. Just a minus x. Cannot combine them because of that exponent. All right, so give your homework a try, and I hope this makes sense. It should be pretty easy, and then we'll work through any problems tomorrow.